In this video, we're going to build a complete 2.5D platformer controller in s&box from scratch. By the end, we'll have left and right movement, walking and running, responsive jumping, Coyote time, jump buffering, variable jump height, faster falling, a side view camera, citizen animations, a locked 2.5D movement plane, and a simple fall respawn system. We'll also set up a reusable player prefab, drop it into a test scene, and make sure the camera and animations are working correctly. First, create a new s&box game project. For this project, I'm calling mine Platformer YouTube, but you can name yours whatever you want. This is going to be a regular game project, and our startup scene will eventually point to a scene called minimal.scene. Once the project is open, we're going to keep the structure pretty simple. We'll have a player controller script, a player prefab, and one small test scene. Let's start by creating the player controller script. Create a folder called Player inside your code folder, then add a new C# file called PlatformerPlayerController. This script is going to be a component that lives on the player root object. It requires a character controller, reads input, changes the character velocity, and then calls controller.move in fixed update. The controller is built around a few main ideas. First, the player uses s&box's character controller. That gives us collision, ground detection, stepping, and basic movement behavior. Second, movement is locked to a 2.5D plane. The character can move left and right on the x-axis, jump on the z-axis, but the y position is locked so the player doesn't drift forward or backward. Third, the visual body is separate from the root object. This means the root stays clean for physics and movement, while the citizen model can rotate to face left or right. A big part of this controller is that almost everything is exposed in the inspector. That makes it easy to tune the feel of the game without constantly changing code. We have settings for input, movement, jumping, camera, visuals, animation, and respawning. For input, the controller uses named actions. By default, the action names are left, right, jump, run, and duck. I also added an option called Use Analog Move Input, but it's turned off by default. That's because in a side view platformer, we usually only want horizontal movement. If analog move is enabled, W and S can sometimes affect movement in ways we don't want. The movement input function checks right and left actions, clamps the value between -1 and +1, and applies a small dead zone so controller sticks don't drift. When the component starts, we automatically look for the required components. We grab the character controller, the skinned model renderer, and the citizen animation helper. Then we configure the citizen animation helper, save the locked Y position, save the first respawn point, and snap the camera into place. The locked depth is set from the player's starting Y position. The respawn point is also set from the player's starting position. And if snap camera on start is enabled, the camera immediately jumps to the correct starting position instead of sliding in from somewhere else. The script uses both onUpdate and onFixedUpdate. OnUpdate is where we read input, update the jump buffer, check if the jump button was released, update the camera, and update animations. OnFixedUpdate is where we do the actual movement logic. That includes timers, horizontal movement, gravity, jumping, locking the 2.5D axis, moving the controller, updating facing direction, saving safe ground position, and checking respawn. The order matters. We calculate the velocity first, then call controller.move, then update things that depend on where the player ended up. Now let's look at horizontal movement. The controller chooses either walk speed or run speed depending on whether the run action is held. Then it moves the current x velocity toward the target x velocity using acceleration. On the ground, the player accelerates faster. In the air, the player still has control, but acceleration is lower. If the player changes direction while already moving, we multiply acceleration by a turnaround multiplier. This makes left to right direction changes feel more responsive. If the player is grounded and there's no movement input, ground friction pulls the x velocity back towards 0. That keeps the character from sliding forever. The jump system has several features that make it feel much better than a basic jump. We have Coyote time, so the player can still jump for a tiny moment after walking off a ledge. We have jump buffering, so if the player presses jump right before landing, the jump still happens. We have variable jump height, so releasing the jump button early cuts the jump shorter. We also have faster falling and apex hang, which gives the jump a more readable platformer feel. Coyote time and jump buffering are both just small timers. When the player is on the ground, the Coyote timer is refreshed. When the player presses jump, the jump buffer timer is refreshed. Then, in fixed update, the controller checks if there is a buffered jump and either Coyote time is still active or an extra air jump is available. This makes the controller much more forgiving.